All right, we're going to talk a little bit more today about velocity and acceleration. We talked about that last time, but I want to talk about the signs of these functions and what the signs of these functions actually mean, whether they're positive or negative. It can cause a little bit of confusion, especially when you're looking at velocity and acceleration at the same time. So I just want to clear up any misconceptions or any concerns or any confusion that might be out there. We already know about position. We measure position using the s function. And if s is equal to 0, then the object is at the origin. All right, so s just tells us where the object actually is. If s is greater than 0, then the object is to the right of the origin. And if s is less than 0, then the object is to the left of the origin. So kind of where the object is on the number line. The negative numbers are to the left and the positive numbers are to the right. All right? So now let's talk about v, velocity, which is the first derivative of position. If the velocity is 0, that means that the object is at rest, even for a moment. That means that the object might simply be sitting still, or it might be changing direction. All right, going from moving to the right to moving to the left. So if the velocity is 0, the object is at rest. Maybe it's for a long time. Maybe it is just for an instant. All right, if the velocity is greater than 0, then the object is moving to the right. Okay, so remember, velocity measures change in position, so the position is becoming more positive, which means the object is moving to the right. And then conversely, if the object is moving to the left, that's going to be shown with a negative value for v. Okay, so wherever the object is, if the change in position is becoming more negative, then the object is moving to the left. All right? So let that sink in a little bit. Now let's talk about acceleration, which is the first derivative of velocity, and it is the second derivative of position. If acceleration is 0, then the velocity is constant. The object may be moving, but it's not getting any faster or slower. It's maintaining a constant velocity. So that's what it means when acceleration is equal to 0. If acceleration is greater than 0, then the velocity is increasing. It is getting more positive. Can't really say more than that without combining it with velocity, and we're going to do that in a minute. And finally, if acceleration is less than 0, then the velocity is decreasing. Okay, and again, I can't really say more than that without combining it with velocity. All right? So those 9 things are how we look at position, velocity, and acceleration. So now let's combine velocity and acceleration to see what it means with all types of signs. So if the velocity is greater than 0, that means that we are moving to the right. And if acceleration is positive, that means that the acceleration, or the velocity rather, is getting more positive. It was already positive to begin with, and now it's getting more and more positive. So I can say that the object is moving to the right and speeding up. That makes sense. Okay? And if I only change acceleration, if the velocity is still greater than 0 and the acceleration is less than 0, that means that the object is moving to the right, but the velocities are getting more and more negative, or less and less positive, however you want to think about it. So the object is slowing down. All right? Now, here's where things get tricky. If velocity is less than 0, that means I'm moving to the left. And if the acceleration is positive, that means that the velocity is already negative, but the velocities are getting either more and more positive or less and less negative. Okay? So my velocities are increasing. That means, and they were negative. Okay? So if the velocity is less than 0, but those velocities are getting less and less negative, or more and more positive, that means that the object is slowing down. Okay? And if I think of it this way, the last possibility, if the velocity is less than 0, meaning that it's 0, and the acceleration is less than 0, that means that the velocities are decreasing, meaning they're getting more and more negative. That means that the object is moving left and it is speeding up. Okay? That may take you a little bit of time to figure out, but that's kind of how I think of it. If the velocities are negative, but they are getting less negative, that means that the object is moving left and slowing down. If the velocities are negative and they are getting more and more negative, then the object is moving left and speeding up. Okay. So, in general, the only time I was speeding up was when the velocity and acceleration were both positive, or when the velocity and acceleration were both negative. So in general, if the velocity and acceleration have the same sign, then the speed is increasing. Okay. Speed, remember, is not something that can be positive or negative. It's just an absolute value. And in general, if velocity and acceleration have different signs, then the speed is decreasing, obviously. All right, so let's look at an example. Here's a particle moving in a straight line. The position function is s equals t cubed minus 3t plus 1. So let's look at the velocity function and the acceleration function. All right, velocity is going to be the first derivative of position, and that will be 3t squared minus 3. The derivative of that 1 is nothing. And then to find acceleration, I'll take the derivative of the velocity function that I just wrote down. All right, and that will be 6t. Okay? So let's talk about the motion of the particle at time 0. Well, velocity at 0 is -3, and acceleration at 0 is 6. No, it's not. Sorry. I can multiply by 0, I promise. Acceleration at time 0 is 0. So what that means is the object is moving to the left because the velocity is negative, and it's moving constantly to the left. It's not getting any faster or slower. At what time does the particle change direction? And we talked about that as being the time when the particle is momentarily at rest. That means the time when the velocity changes from being positive to negative or negative to positive. It's that time when the velocity is 0, just for an instant. Okay? So that will happen when 3t squared equals 3, or when t squared equals 1, or when t is plus or minus 1. I'm not going to talk about -1 because time starts at 0 and moves forward. So the only time I'm going to consider is 1. All right. So this thing moves along, and then after 1 second, it moves in the other direction. All right. So what is the total distance traveled in the first 2 seconds? Well, let's see. At position, or at time 0, the position was 0 cubed minus 3 times 0 plus 1. So it was at 1. At the time when it changed direction, that was after 1 second. So I need to know where it was after 1 second. Okay? So 1 cubed minus 3 times 1 plus 1, that should be -1. Okay? So between the 0 second mark and the 1 second mark, it traveled a distance of 2 centimeters. Okay? And then I want to know where it was after the 2 second mark. Okay? And if I plug in 2, 2 cubed is 8, minus 6 plus 1, that should be 3. And so here it moved a total of 4 units to get from -1 to positive 3. So the total distance was 6 centimeters. Okay, I have to consider the fact that it did change direction. If I just looked at what happened at 0 seconds and then at 2 seconds, that would only give me the displacement, the difference between where it started and where it stopped. That's called displacement. If I want the total distance, then I need to consider the possibility that it moved in one direction and then stopped and moved in the other direction, which is exactly what happened. So it started at a position of 1, it went backwards to -1, and then it moved back forwards to +3. So I need to consider all of that. So when you're finding total distance, you need to consider those times when the particle changed position. And I figured that out by setting the first derivative equal to 0 and solving for t. That's if I'm looking for total distance traveled. Okay, I'll have to look at all those intervals where the position or the object changed direction, and you do that by setting the first derivative equal to 0. So that's a lot of information, and I will be able to help you. So ask me any questions, email me any questions, and we'll see you tomorrow.